Welcome to the video for skill number 76. I can calculate the volume and surface area of composite shapes. For this skill you need to be successful with skill 71 to 75 because it requires volume and surface area calculations of all of the basic geometric volumes. Those volumes would be prism, cylinder, pyramid, cone, and sphere. And what I've done here is I've created a table which takes everything we've learned over all of the last previous skills and laid them out for us. So the lateral area, the surface area, and volume equations for each of the shapes. We should focus most on right prism, right cylinder, regular pyramid, right cone, and sphere. So with those we can find composite surface area and volume. And the way we do that is we calculate that by decomposing objects into individual volumes and surfaces. And we'll see this with a diagram on the next page of notes, 76b. So in example 1 what we have is we have a rectangular prism, a right rectangular prism that has a cone carved out of it. And we need to find the surface area and volume of the diagram. Well, the easiest way, or the easiest piece, is to find the volume, because first we find the volume of the prism, which is base times height. And so I did base times height, and that gives you the volume of the prism. And then we're going to subtract out of it the cone. So the cone goes from the top down to the bottom, and the area, the calculation for the volume of a cone is 1/3 pi r squared times height. So 1/3 pi times our radius of 2 squared, and our height is 4. So 1/3 pi 2 squared times 4. If we simplify each of those values, we get 200 for the prism and 16.75 for the cone, and we can subtract one from the other and get a total volume of the object at 183.2 inches cubed. The surface area calculation is going to be a little bit harder to do. What we have to do is kind of piece together what's going on in our head. So what we have is the surface area of the prism. So we can take all of the prism, all of the surfaces of the prism, and then from that we're going to have the lateral area of the cone. So the cone piece, not the whole cone, but the lateral area of the cone. And then we have to subtract out this circle, which is equal to the base of the cone. So if we subtract out the base of the cone, that allows us to think of this as kind of a hole in the top of the prism. So surface area of a prism is lateral plus 2 times the base. So the lateral area is perimeter times height, and the base is length times width. And that's how we find the surface area of the prism. Simplify that out. The prism is 220 inches squared. And then we're going to add the lateral area of the cone, and the lateral area for cones is pi r slant height. So we need to find the slant height of this cone, and I've done that by drawing a right triangle and finding the hypotenuse, because that will be the slant height of the cone. You can imagine that this triangle right here is that part of the diagram. And we find that the lateral area of the cone is 28.099 inches squared. And so that is going to be this surface here all the way around. And then finally we subtract out the base of the cone, and base for a cone is a circle area, so pi r squared gives us a base of 12.56. And that would be this circle that we are taking out of the drawing. So altogether our surface area is going to be surface of the prism plus the lateral of the cone minus the base of the cone. And we crunch those numbers here, giving us a value of 235.5 inches squared. In our second example, we have two shapes added to one another. The last one we had a shape subtracted from this prism, and now we have a hemisphere placed on top of a cylinder. So to find the volume of this object, we would want to find the volume of the cylinder and add to that the volume of a hemisphere. So our volume calculation is pi r squared times height, and that'll be our cylinder. We take pi times 20 squared times 76, and that gives us the volume of the cylinder. And then the volume of the hemisphere is going to be a sphere cut in half. So 4/3 pi r cubed divided by 2. And if we simplify all of that out, we get a volume of approximately 112,259.58 feet cubed. For a surface area, what we want is we want to get the surface area of the hemisphere, and then we're going to add to that the lateral area of the cylinder, and then we're going to add to that the base of the cylinder. So those three pieces make up the outside surface area of the object. So the hemisphere, the surface area of a hemisphere is going to be half of the surface area of a sphere. So we take our 4 pi r squared and we cut it in half. That's our surface area of the hemisphere, the part that's exposed. And then we add to that 2 pi r times height, and that gives you the surface area of the hemisphere, or the cylinder. And then finally we add the base, pi r squared. So I've shown each calculation. Hemisphere is roughly 800 pi, and this would not include the base because the base is not exposed. And then the lateral area of the cylinder is 3040 pi, and that's just essentially the walls of the cylinder. It does not include the two bases. And then finally we add the bottom base of the cylinder because that is included, and that's 400 pi. If we add those three together, we get a surface area of approximately 13,320.35 inches squared. Alright, the key ideas and concepts for this video is being able to apply all of the lateral area, surface area, and volume equations together. And on the skill, I may give you something that looks like a rectangular prism on top of a rectangular prism and ask you to find the area, surface area, and volume of that shape. Maybe I'll take a cube, and on top of the cube I'll put a hemisphere and ask you to find the surface area and volume of that. Basically, I'll be combining various shapes that we've done calculations on and ask you to find surface area and volume. Here's a pyramid on top of a prism, and then we have a pyramid on the bottom of the prism as well. So any possible arrangement, and you should be able to apply all of the formulas to arrive at the answer. Alright, thank you.